Hello students, welcome back. So now we are going to be performing univariate analysis on numerical column, and I'll be focusing more on descriptive statistics in this particular session. So first thing I'm doing is importing my necessary libraries. These last two libraries, these are primarily for your visualization purposes. So in this particular instance, I can either read my pickle file that was actually saved in my step one, or I can actually read CSV file. In this case, I'm choosing to go with CSV file. No reason, just I feel like using CSV file. That's all. So in this case, let's print out 10 sample values. So just to get a feel of your data. So in this case, you can see that your MPG, it seems like decimal number right here because there's a point over there. Likewise, your horsepower seems like decimal number. Your cylinder, they seem like a whole number right here. And you can actually get a little bit insight into your data from here. You can see that your origin and name, these are like text characters. Okay, you can also print out the memory usage in this case. So I'm using info, and that tells me the data type for each one of the columns. For MPG, it's float 64. That's the data type. Cylinder int 64. Anytime you see float 64, that should tell you that it is using decimal numbers. Anytime when you see int 64, that should tell you that these are like whole numbers. And then you have objects, right? So over here, that's telling me my origin and name. They're very likely they are basically your string character, they're text characters. At the end, it also tells you like how many float 64 are there. There are 4 columns with float 64, 3 columns are int 64, and 2 columns are object type. It tells you right there. You can see that 2 of them are object. Also tells you the memory usage. So let's identify numeric columns in this case. So in this particular instance, these are numerical columns I'll be using: MPG, displacement, horsepower, weight, and acceleration. In this particular instance, I manually pick up these columns. If you want to see some records of the numerical columns, so in this case, df numeric columns dot head, that's going to print out the first 5 records of your numeric columns. These are my first 5 records of numerical columns. Now let's look at the descriptive stats on these numerical columns, these ones right here. So in this particular instance, I'm calling the inbuilt method describe on that numerical column. So it prints out these values right here. So let's focus on one column, MPG. And likewise, once you understand MPG, you can figure out the rest of them. So in this instance, it's telling me that the total count for MPG is 398. There are 398 records. The average value, the mean value for MPG is 23.5. The standard deviation for MPG is 7.8, and the minimum value is 9, and the maximum value is 46.6. In other words, your values for MPG, they go from 9 to 46.6. The 25th percentile is 17.5, and the 50th percentile for MPG is 23, and the 75th percentile is 29. So let's understand this. Let's understand all this on the MPG. So there is a famous empirical rule that says something like this: 68, 95, 99.7. And basically what it says is something like this, that about 68% of your data, it lies within one standard deviation of the mean. In other words, 68% of your data will lie between mu minus sigma and mu plus sigma. Mu is your mean value. Likewise, 95% of your data is going to be lying within 2 standard deviation of the mean. In other words, 95% of data will lie between mu minus 2 sigma plus and mu plus 2 sigma. So between here to here. And your sigma is a standard deviation. And likewise, 99.7% of your data will lie between mu minus 3 sigma and mu plus 3 sigma. So this is your famous empirical rule. So now let's apply this empirical rule on your MPG column. We know for that particular column, your mean is 23.5 and your standard deviation is 7.8. So according to the empirical relationship, 68% of your data lies between mu minus sigma and mu plus sigma. So in this case, I'm just substituting my value of mu, which is my mean, and substituting value of sigma, that is your 7.8. And running this, it gives me these values. So 68% of my data has MPG between 15.7 and 31.3. That's what this statement is. Let's do this for those within 2 standard deviations. So in this case, I'm multiplying 2 by 7.8 plus 2 times 7.8. So this is going to become mu minus 2 sigma, mu plus 2 sigma. When I run this, it prints out these values right here. So 7.9 and 39.1. What does it mean? It means that 95% of my data has MPG between 7.9, that would be this value, and 39.1. That's what this statement is. Okay, what about this one? Within 3 standard deviation. Well, it means when you run this that 99.7% of my data has MPG between 0.1 and 46.9. That's what this statement means. Okay, let's look at the MPG data, and you will see that approximately 60% of your MPG data, it would lie between 15.7 and 31.3. I just want to verify this statement. So what I'm doing, I'm actually printing out my MPG data. I'm putting this in the form of a list, and I'm sorting it out. And then I print my MPG right here. So let's see if this statement actually is true. So let's find my 15.7. So 15.7 would be somewhere, just come over here. I would say somewhere over here. Yeah, somewhere over here. 15.5, 15.7, somewhere over here. So it's telling me that 68% of my data is going to lie between this and 31.3. 31.3 would be somewhere over here, right here. So there you go. Let's just put a mark over here. So 68% of my data lies between this and this value right here. So this data right here, all these values, they are basically approximately 68% of your data, all the way up to here. Okay, from here to here, this is your 68% of your data. Okay, let's look at the other one. Let's verify this. Let's verify the above statement on kernel density estimation curve. So in this case, I'm just plotting my KDE. I'm also putting the DFMPG, the describe status on that. So when I run this, this is going to actually print a black background, changing my figure size, and my X would be MPG, and my color I just want orange. And when I plot this, it gives me this right here. Let me decrease the size of the screen so it's more visible. There you go. Okay, so in this case, total count for MPG is 398. The mean value is 23.5. And you can see that if you look over here, 23.5 would be somewhere over here. So yeah, this is your KDE. So the mean is falling somewhere over here. That makes sense. Standard deviation is 7.8. So that means if you go, if your mean is 23.5, so you go 15, let's see, 23.5 minus sigma, 23 plus, 23.5 plus sigma, so that would be 15.7 and 31.3. So 15.7 would be somewhere over here, and 31.3 would be somewhere over here. That means 68% of my data would lie between over here and over here. Okay, so this is where your MPG, sorry, 68% of your MPG, the values are in this range. That's what it's telling you. Okay, and then it tells me that 25th percentile is 17.5. So 25th percentile would be 17.5 would be somewhere over here. So that means 25% of our data, it's on this, it falls below that value, below 17.5. Okay, and so likewise you can derive, oh, another thing is minimum value and maximum value. So minimum value is 9. So this is 10. So 9 is somewhere over here. Since this is a smooth curve, so that's why it's going like this. And 46 would be somewhere, I would say, over here. So that means your MPG falls between 9 to 46.6 right. So it kind of makes sense by looking at this curve. Now for your MPG, the 25th percentile was 17.5. What do you mean by that? It means that 25% of your data has MPG less than 17.5. 50th percentile was 23. Your Q2 was 23. Another name for 50th percentile is Q2, by the way. And likewise, another name for 25th percentile is Q1. So this statement right here, it means that, oops, sorry, this means that your 50% of your data has MPG less than 23. Now, the range of my MPG is from 9 to 46.6. So let's look at the data. Let's look at the MPG data visually to verify if all these three statements do they even make sense. So in this case, I'm printing out my MPG right here, and you can see that the minimum value is 9, and it ranges all the way up to 46.6. All right. So this statement makes sense. We verified that. What about this one right here? It's saying that 25% of your data has MPG less than 17.5. So where is my 17.5? Come over here. Ah, look at that. This is your 17.5. So this is telling me that approximately this data, okay, from here all the way up to here, keep going, keep going, keep going up to here. This is my 75% of my data. That's what that is. So all this data is 75%. Okay, what's the other statement? Other statement was that 50% of your data has MPG less than 23. So let's find 23. Let me decrease the size of the screen. All right. So let's find 23. So in this case, 23 would be somewhere, keep going. Yeah, there you go. This is my 23 right here. So that means 50% of my data it is below 23. That is, all these numbers, they are approximately 50% of your data. And if you look at this data right here, it does kind of make sense. Yeah, this almost represents 50% of your data. All right. So visually, we verified that whatever statement, whatever information we derived, it does kind of agree with what we observe. You can also find minimum and maximum value of numerical columns. So in this case, there's a df numeric dot min. Min actually is an inbuilt method that's going to return the minimum for each one of them. So when I run this, it's going to give me the minimum for mpg is 9, the minimum value for displacement is 68, and the minimum for horsepower is 46. Likewise, if you want to do the maximum, you can comment this one out, and that's going to print out, when you do dot max, that's going to print out your maximum. And for this thing, it tells you that the maximum for mpg is 46.6, for displacement is 455. So basically it's telling you that mpg, it goes from 9 to 46.6. Displacement, the minimum is 68 and the maximum is 455. It kind of gives you the range of values for each one of the columns. And you can also print out the variance and standard deviation of your numerical column. So in this case, you're saying print df numeric columns right here, and then you call the inbuilt method var, which is a short for variance. So in this case, let me comment this thing out. So when I run this, it's going to print out the variance for each one of the columns. For mpg, the variance is 61. For displacement, these are the values. If you want the standard deviation, you can do that too. So just call the inbuilt method std, and that's going to print out the standard deviation for each one of these columns right here. Well, if you want to calculate the percentile explicitly, you can do that too. So these are my numerical column right here. You just call your data frame with numerical column, index them with numerical columns, and then you specify quantile. And inside quantile, you specify which one you want. In this case, I want 50th percentile. So that's going to give me your Q2. So when I run this, it prints out the 50th percentile. So let's just come over here, 50th percentile of each one of the columns. For MPG, the 50th percentile is 23, for displacement is 148, and likewise for the rest of the column. You can also print out the 25th percentile actually, or 70th percentile, or 90th percentile. You can just uncomment any one of these lines out, and that's going to print out your 90th percentile. This will print out your 75th percentile, or 40 percentile, 50 percentile, depending on whichever you want. Uh, what if you want to print out your multiple percentiles? Maybe you want to print out 25th percentile and 50th percentile and 75th percentile for all the columns. You can do that too. So when you run this, it prints out all these values. So let's look at this value. This is basically for horsepower. It's saying that the 50th percentile for the horsepower is 93.5. And this one right here, this is telling me that for the column acceleration, your 25th percentile is 13.825. And then you can calculate the median of numerical column. If you recall, median is the middle value. So in this case, when you run this thing, it's going to give you the median of these columns. So the median of MPG is 23. For displacement is these. These are the different values for each one of them. And then there is a mode. You can also calculate the mode. So let's say these are my columns, categorical columns, cylinder and mode here, right here. And I want to know that let's come over here, and I want to know what is the most common occurring value. Mode, if you recall, that's what it is. It tells you the most common occurring value. So when I run this, it tells me, let's come over here. Where is that? Oh, there it is. When you run this, it tells me that for cylinder, the most common occurring value is 4. For model year, the most common occurring value is 73. If you want just an individual, you can do individual too. You don't have to do it the whole thing. You can just come here and comment this thing out. When you run this, it's going to print out just for the cylinder. So for cylinder, the most common occurring value is 4 right here. Okay, let's verify each one of them. Let's just see it makes sense. So in this particular instance, I'm saying df cylinder dot value counts. I want to know value count for each one of them. When I run this, it tells me for the 4, if you have 4-cylinder cars, there are total 204 records. So clearly your 4 is more. So you can see that for cylinder, it is 4. What about model year? So now I'm doing the value count on the model year. And it's telling me for the model year 73, there are total 40 records. For the year 78, there's 36 records. So this one has the highest frequency. So that's why it shows 73 as your model, as your mode for the model year. And now if you want to look at all the stats in one single chart, you can do that too. So in this case, you can use the AGG function, short for aggregation. So in this case, you specify your numeric column. These are my numeric columns. and you call your the data frame, and you just index your numerical columns, and then you specify what you want. I want count, I want mean, median, standard deviation, variance, minimum, maximum. And when you run this, it's going to print out these values for each one of these columns right here. So let's look at this one right here. This one is telling me that for displacement, the standard deviation is 104. Likewise, you can read the rest of the stats from here.